Cryptography is the method of protecting information and communication through the use of code, so only those for whom the information is intended can read and process it. Cryptography is used for many things, from online banking to GitHub commits. Today, we'll dive into the basics of cryptography, so let's get started. Welcome to the Ladybug Podcast. I'm Kelly.
I'm Sydney.
I'm Allie.
And I'm Emma, and we're debugging the tech industry. What are your experiences with cryptography? Kelly, do you have any experience with cryptographic
First of all,
things?
You've been in Sweden for too long because you've forgotten how to speak.
I know.
Second, I have no experience with cryptography. This is all new to me. Like, I've been given things to enter in, but I have never actually configured anything that involves doing anything with cryptography. So this is totally new to me.
Sweet. Allie, what about you?
Yeah, pretty much the same. I have taught authentication a bunch of times, and sometimes like some cryptography stuff comes up in that, but other than that, really not much at all.
It's just funny because it sounds like a really scary area. It sounds like you're in the FBI and you're trying to like hack the mainframe. I guess that's what I think of when I think of cryptography. And to some extent, I think it's true. Like, that's what they're doing when they're hacking into things, is they're trying to break through these cryptographic algorithms. I don't really even know what to call them. But so my experience is I took a class on cryptography in college. I was taking it pass-fail, which meant basically all I had to do was pass the class, and I didn't get a letter grade associated with my grade point average. I just had to pass it. And so we only had a midterm and a final, and I bombed the midterm. I think I got like a 40%. And then my college counselor came to me and like, oh, sorry, you can't actually take this pass fail. You actually have to get a grade for this class. And I was like, oh no, like I'm so screwed. Like I just bombed my cryptography midterm and there were only 2 exams. So I went to my professor and I just cried to him. And I was like, please help me, help me study. And so I studied my butt off for the rest of the semester. And I ended up with a B in the class, which was really good. But yeah,
that's great.
It's hard. It's definitely not easy. But it's funny because I did actually receive a job offer from IBM to join their cryptography team. When I got my first job straight after my internship, it was between a cryptography job in New York at Poughkeepsie or an enterprise storage job in Austin, in Texas. And so I took the one in Texas, but I was offered a cryptography position. It's just, I don't know. It's hard. And honestly, it wasn't my passion. But we're talking about it today because I still think it's really interesting, and at least the foundational aspects are decently approachable. So
yeah, and I am totally cool with somebody who got to be in the class teaching me everything I need to know about cryptography.
Yeah,
perfect.
same.
All right, well, let's unlock the secrets of this episode.
But
okay, so what is cryptography? You kind of heard a little bit about that in the intro, but it's essentially just a method of protecting information and communication through your code or through the use of code, so only those for whom the information is intended can read and process it. So the prefix crypt actually means hidden and or vault, and the suffix graphy, I can't really say that properly, but that means writing. And so hidden writing is what that word means. And there are...
This is a little bit morbid, but isn't a crypt where they keep dead people?
Yeah, in Paris,
yes,
they have the underground crypts that I visited, and it's literally just walls full of bones. So, yeah, I guess it probably comes from French to some extent, or a French. Is French a Germanic language? I don't know. It doesn't really matter.
It has a Greek origin. Kryptos.
Oh, that's cool.
That makes sense.
Yeah, it does.
Also Latin crypta.
I like this is turning into an etymology course.
I did not take Latin.
Or etymology episode. But in any case, there are 4 main objectives of cryptography. What do you think the first one could be? If you were trying to make something secure and safe, what is one of the things that you would want it to be?
Well, we have the sheet in front of us, so I feel like it's cheating.
I'm trying to do this as if we're in a class, but in any case, yeah.
Well, okay, I know I'm reading it, but based on what you said, my first one I would go to is the authentication process of it. Because if it's going to be kept safe, I need to actually authenticate, be able to do anything.
Yeah, that's true. It's like you need to be able to validate someone's identity. Like, how do you do that electronically? How do you validate someone's identity over the internet? Allie, you probably have way more experience with authentication than I do. I have not done anything with auth.
Yeah, I used to teach Passport JS a lot, which is like a node library for authentication. It's like wild how much work it is compared to something like Rails or Django authentication, where you can just like kind of turn it on. You have to do a lot still to get authentication within Express. So that's pretty much my experience there. But yeah,
I've got experience with OAuth,
So what is that exactly?
which I use for it's a protocol that's used for authentication. We use OAuth to authenticate that I am if I build a Shopify app, for example, OAuth is what uses to authenticate that I have actually installed that app and I should have access to this, and I should have access to everything from Shopify's API in order to like pull products and pull orders and things like that. So I have to authenticate to actually receive that information. So that goes through the process of OAuth.
Perfect. Yeah, I haven't worked with authentication at all. It's something I'd always wanted to work with, like build a simple login application with OAuth or something. I don't know, but I'm sure some of our listeners have worked with it. But yeah, authentication is one of the 4 pillars of cryptography, or the 4 objectives. Another one it makes sense once you hear it stated, is confidentiality. Like, you want to make sure this information can only be understood by the person for whom it was intended.
Oh, yeah. One of the biggest rules with authentication is never storing passwords in plain text, no matter where that password is. And so this kind of goes with that, let's say.
It's always an interesting conversation I have to have with merchants when we're migrating them from one platform to another, as to why customers need to set up their customer accounts again, that we can pass over like the email address and like create an account for them, but they have to set a new password. So like, why can't you just move the password over? Like, I don't have access to their password. I should never have access to their password. So it's a blocker, but it's a necessary blocker for security.
To be honest, like understanding how keys work with enterprise applications is something that I still struggle with and did struggle immensely with. At IBM, it just kind of felt like something that everyone around me knew they needed to be doing. Like, oh, you need to store your key in a private file and don't commit it, like all these things. But we're not taught this. I was not taught this in my computer science degree, and I was never taught this like ever. So I always struggle with authentication and confidentiality and things of that nature. Don't tell my job that.
I just tweeted at them, so it's too late.
Cool. Nice. So kind of along the same lines of, your information shouldn't be understandable by someone for whom it was not intended. I said that really confusingly. It should only be understandable to the people you want to read it. It should also never be altered in any way. We want to make sure that someone can't intercept it and change the contents. That could be really harmful. And this, as we'll see later in this episode, is really important if you're at war. And this was a huge thing back in the day during war, when they were sending and receiving transmissions about their, like, I don't know, what am I looking at? Strategy? Yeah, I guess that's the word I'm looking for.
Yeah.
So integrity is definitely an integral part of cryptography. So the last objective of cryptography is non-repudiation, where the creator or the sender of the message cannot deny at a later stage their intention in the creation or transmission of information. So it's kind of like they send a message and, I don't know, if someone were to intercept it, the sender can't come back and say, oh, I didn't do this. So that's the 4th objective. And it seems like there's a pretty straightforward process for cryptography that is followed, I would assume, as well in many modern web apps, right? Like, to Allie's point, you shouldn't be storing your passwords in plain text, right? We have to encrypt our keys. So it starts out as plain text. We encrypt it using some encryption method. At that point, it becomes non-readable. It's encrypted data. And the receiver is going to decrypt that message using a key or some other method, and it will eventually return to plain text. So that's kind of the overall process. Are any of you available with the different types of cryptography? Have you heard of like single key or symmetric key encryption or public key?
Yeah, I mean, public keys, I've like GitHub, I've used it across that. There have been a couple other scenarios that I'm completely blanking on where I've had to generate a public key or enter it in somewhere. I'm still like, I'm still not past non-repudiation because I'd never heard of that word before either. And I Googled it, and I mean, I guess it applies to other scenarios. Like Wikipedia gives the example of Mallory buys a cell phone for $100 and writes a paper check as payment and signs the check with a pen. Later, she finds she can't afford it and claims that the check is a forgery. Unfortunately, the signature guarantees that only Mallory could have signed the check, and so Mallory's bank must pay the check. This is non-repudiation. She cannot repudiate the check. But it's been like apparently like the general use of it is specifically in terms of digital security, which is something that's really interesting to me. It's like it came about specifically for digital purposes.
It must have been a big issue. Like that must have been a huge issue back when, you know, with people trying to play off the fact that they did or did not send something.
Yeah. So kind of interesting.
It kind of reminds me of like modern day issues would be like deep fakes. Like, oh, I didn't say that. You know what I mean? Is that maybe that's like a common example of non-repudiation is like, how do we prove that something is or is not like, valid?
Yeah.
Nuts. But
I think in terms of like signing a contract as well, like, no, your digital signature is actually valid and you did actually sign this. And yeah, so very interesting.
Yeah. So the first type of cryptography we'll talk about is single key or symmetric key encryption. So with this type of encryption, you create a fixed length of bits, which is known as a block cipher. And you have a secret key that the creator or the sender uses to encipher data. And this is the actual process of encryption. And then the receiver is going to use this to decipher it. So one example is going to be the Advanced Encryption Standard, or AES. And it was a standard published in 2001 by the National Institute of Standards and Technology as a federal information processing standard. There's so many like acronyms in this, I can't handle it. But yeah, this seems to be a pretty straightforward, pretty popular method of encryption. We'll talk a little bit more about ciphers in just a minute. But to be honest, I don't know that much about symmetric key encryption. It just seems like, okay, we've got a secret key that, you know, the person receiving this message needs to have in order to read this message, and you're good to go. It seems pretty straightforward.
Yeah, there's like a hashing algorithm, right? Which is how the text or whatever is actually encrypted, and then the inverse of it is used to decrypt it, right? I don't know.
Yeah, I think
and then
so.
You have a salt that starts the process as well, which is like some sort of phrase that you provide to start the hashing algorithm.
You know a lot about that. I actually know not that much about like single key or symmetric key encryption.
I don't know. At least that's my experience with it. The next one that we're going to talk about, though, is public key, which you have to do for GitHub, right? In order to get SSH working for GitHub.
Yeah. So do you want to quickly talk about that? And also, can you define what SSH means?
Oh, I have no idea what it stands for, is what I'm now learning. But SSH is when you essentially like connect to a server via the command line.
It stands for secure shell.
Okay, there you go. Secure shell.
I asked you that not for our listeners' benefits, but for mine.
Okay.
Because I didn't know either.
No, okay, cool. But normally if you want to get onto like a remote server, you'll have to SSH onto it. But then GitHub allows you to clone and push and connect to GitHub in two ways. One is via HTTP, I think, and then which is not what I use, but then there's also the SSH method. And in order to do that, you have to set up the public keys on your computer. Do you all use the SSH version or the HTTP?
I mean, I've been using HTTP version, but I've used other SSH things in the past. And maybe I do. It's been so long since I've actually looked at my configuration that I don't remember. But I was just looking at a list of SSH clients because it's been a while. I used to do things with SSH that I just completely forgot about. And there were a couple clients that I had recognized by name, like OpenSSH and Putty.
Yeah, Putty. I definitely used to use that in college, actually, to submit assignments. We had to have this server that stored all of our homework on it, and so we'd have to SSH using Putty. But I like a little bit more modern. I've used SSH to get onto servers at work and stuff. But
yeah.
I think the SSH, just is just a pro tip. Every time that you do the SSH version of GitHub, you have to set it up on new computers. So you would probably know. But I find the user interface for it much more straightforward, and it works more consistently than the HTTP. So I don't know if anybody's listening to this, strongly recommend the SSH version of GitHub or the GitHub CLI. This is now totally tangential.
That's okay. I think I actually do use SSH.
I think I do too, but I don't remember. But what I don't understand is why even bother having a public and a private key? Like, what's the benefit? And like, if it's public, like anyone should know what that is, right? So why even bother? Why don't you just have the private key? That's what I don't get. I don't understand how it works. So
I'm not totally sure either, to be honest.
Yeah, I don't understand. Okay, so one example of...
It's because I think one gets sent to the server. And so if you only had a private key, then it's no longer private because it has to be sent to a server. Whereas the private key will always stay with you and only you. So they mapped together, but whatever you expose to a server, that's what's actually going to be shareable.
Oh, I wonder, I think
it's meant to be like a protective
measure. We could equate this to like, so in Europe, as many apartments as I've been in at this point, everyone has the same key for the front door to get in the building, but then you've got your own private key for your apartment. Maybe it's something similar. That's a good analogy. One example of... what is this? Asymmetric key encryption is the RSA algorithm. And this stands for, oh my gosh, I can't pronounce their names. But essentially, this acronym is 3 last names. I think of probably the founders or the creators of it. And RSA is an algorithm that's used by computers to encrypt and decrypt messages. Shocker. Because that's what we're talking about. But so asymmetric, yeah, it means there are 2 different keys. So from what I can read, yeah, one of the keys can be given to anyone and the other one has to be kept private. I just don't understand.
I had no idea that RSA was an acronym for the inventors of RSA.
Yeah.
That's fascinating. It's like Rivest, Shamir, and Edelman. Yeah. Interesting.
Just think it's interesting how this is so mathematical. It's like, it deals a lot with permutations and, oh gosh, this is why I did so badly, because I'm not good at that type of math. I always did really badly in those types of math classes. And so maybe that's why, like these, if you go look at the Wikipedia page for the RSA algorithm, it's just like a lot of like theta. And I see Greek symbols and I just shut down. I can't. So maybe that's why I didn't do great at cryptography, which is why it's so great that I'm teaching this to you all today.
You know, I never realized, like, I use RSA a lot. Like, when I was working at CDC, for example, we had, like, the hard RSA token that would, like, goes on our keychain that just regenerates a new 6-digit number every 30 seconds. And that's what we use to actually authenticate into the system at CDC.
That's what I use at Spotify. They have the Google Authenticator app, yeah. Those are really nice because you can get push notifications that you can accept, or you have the 6-digit turned over like values that you have to input into a website.
I was trying to understand, like, is there a difference between like 2FA via something like Authy or Google Authenticator and RSA?
I don't know.
Or is that literally what it is?
I don't know.
I'm not sure, like, because they're all 6-digit codes. I also have one from Symantec as well. Like another app that does a 6-digit code.
I don't know. From everything that I'm looking at right now, it doesn't explicitly state that multi-factor authentication is a type of encryption, or it doesn't equate it to RSA as far as I can tell. But essentially, it's just like, I would assume that multi-factor authentication is a type of cryptography. It ensures the integrity, right? What are the other 4 aspects that we talked about? Integrity.
There's the whole authentication piece of it.
Right.
Non-repudiation. I'm never going to forget that word now.
So I think, yeah, I would say multi-factor authentication is like a type of cryptography. Now, what's going on under the hood? I don't know. I couldn't tell you. So to maintain this data integrity, we use these things called hash functions that Ali previously mentioned. And basically, Ali, do you want to explain at a high level what a hash function is?
Ooh, I'm not sure if I can do this justice, but essentially it's a function that does this encryption. So it takes some sort of, it takes somebody's password and then it encrypts it according to the algorithm that you have defined.
Yeah, so I think that definition that I found said it returns a deterministic output from an input value, and it's used to map data to a fixed data size. So I guess given the same input, it will always return the same output. But, we just talked about GitHub. GitHub commits use SHA, and SHA stands for Secure Hash Algorithm. And so we've got SHA 1, 2, and 3. And honestly, I don't know the difference between any of them. But I never realized that commit messages were secure hash algorithms and like how it all works. It's very interesting.
I also like in our show notes that you have on here is SHA-1, SHAT-2, and SHA-3.
I told you my English is great. I think at this point the Scandinavians speak better English than I do. But let's talk about a really fun cipher. This one's my favorite. It's one of the quote unquote easier ones to comprehend. I don't like that word, but when we talk about the complexity of different ciphers and different encryption algorithms, I think this one is by far the most straightforward. We'll use straightforward instead of easy. This one's called a Caesar shift cipher. That's so hard to say. Caesar shift cipher. I'm worried I'm going to say something bleepable on this podcast. But this is the simplest encryption method, and it's a substitution cipher where each letter in your plain text message is replaced by a letter that is some fixed number of positions down the alphabet. So let's say we have a left shift of 3. D would be replaced by A, E would become B, and so on. And this method was named after Julius Caesar, who used this algorithm in his private correspondence. What was he writing about that required him to create an encryption method?
Probably war things, would be my guess.
Makes sense.
His diary.
Secret life. This is a pretty common like hacker rank type problem. If you go on those
Caesar shift.
Yeah. Those types of sites. It's not very difficult to implement at all. Well, I mean, relative.
Right. It's like you have like I think the only tricky thing about that would be once you get to the end of the alphabet wrapping around. Like how would you solve that? Like, let's just talk about that for a sec. Cause that is like a decently common problem. Because it's really easy to say, take every letter of the alphabet and map it to a corresponding one, right? You could do it iteratively where you've got a dictionary of sorts or like
what I
object.
Always do is I just do an array or a list of all the letters in the alphabet. So then each one has an index value, and then you can just like subtract 3 or whatever, and then you use a modulo to if you get past the end.
That's super smart. So let's say like you're at index 25, which would be a Z, I believe. And then you've got a shift of 3. What you would, or no, it would be the other way. It would be like if you had a 1, right? And you had a shift of 3. And that would put you at a negative number. Yeah, if you modulus. Am I going the right way? This is very confusing.
Yeah, no, you I think you're good. The other thing is that some languages support negative indexing, like Python supports negative indexing, and then it becomes much easier. So there you go.
Interesting. Nice. So that one was always my favorite cipher, probably because I found it like the only one I could understand. All the other ones I did not do well. So now that we've talked a little bit about the types of encryption, let's talk very quickly about the historical context of this. One example of historical cryptography is the Enigma machine. This was probably one of the biggest examples of how cryptography was used in warfare. So the Enigma machine was a cipher device developed and used in the 20th century to protect military communication, and it was used by Nazi Germany during World War II. It was definitely considered to be extremely secure, and it was an electromechanical rotor mechanism, and it just scrambled the 26 letters of the alphabet. I won't go into the details of how it works fully, but it had something to do with, again, rotor mechanisms, and it had to do with lights and plain text and all of that kind of thing. We'll link a couple resources in the show notes if you want to check out more about the Enigma machine. It's super interesting. But what was really cool is that in December 1932, a Polish mathematician and cryptanalysts used the theory of permutations and flaws in the German military message procedures to actually break the keys of the plugboard Enigma machine. I can't even imagine how do you look at something that complex and intercept the message and just understand how to decrypt it. I don't understand that at all.
You know who can probably do this are Taylor Swift fans who figure out everything before Taylor Swift slips those Easter eggs into everything that she does.
That's true.
That's the modern day
There are a
version
lot of
of
people that should go into cryptography who are just using their powers for social stalking. And I just can't imagine. I don't know. I find the history of computing really interesting, especially as it pertains to modern warfare and like different strategies. But I just don't understand it. I don't think I'll ever understand it. And I don't know. I always envied people who were really, it seems naturally intelligent to be able to look at something and just decipher it. Wasn't like A Beautiful Mind, the movie, like, wasn't he able to do that kind of thing? Was that about cryptography or was that like mathematical equations?
Oh, I've not seen.
I don't
any
remember.
Of these types of
I think
movies.
I thought it was like I know he was like a math genius. I don't know if it had to do with cryptography.
I think a lot of this is math. I think that's why I struggle so much with cryptography in general, just conceptually, is because a lot of it is heavy math.
It's totally, yeah. I now that I think about it, it's totally related to cryptography.
Yeah, it has to be. It's just funny. It's like when people think of hackers or computer programmers, they just think of people hacking mainframes. And it's like I think of cryptography and I think of the main character from A Beautiful Mind, just like all these numbers floating around him and he's just deciphering things. It's probably like if you were to get a job in cryptography, that's probably not what it's like. I can assure you that is probably not like that. But that's what I think of.
It's like people who work on like red teams and stuff for like hacking. It's like not that they just sit there and just like they look like the hacker on television doing or on movies.
That's the
doing all the
glowing
things.
green terminal.
Yep, that's all they do.
Yeah.
Just rapid typing in that.
For sure. For sure. I don't know. I think something that we should talk about as well is that probably rolling your own cryptography algorithms in applications is probably not the way to go if you're like us. Just from a security perspective, it's probably going to be better if you used a managed authentication service. So something like Auth0 or Amazon Cognito, or I'm sure there are many others out there that you can use their authentication systems that they have created instead of doing all this yourself.
Yeah.
I just think
don't try to reinvent the wheel and be creative here. Security comes
exactly,
first.
Exactly. Especially not using like the Caesar cipher or whatever, because that's to store your password, because that's pretty easy to crack just looking at it.
Yeah.
So I would definitely recommend those. It makes it so that it's like a couple lines of code to get authentication instead of having to write a hashing algorithm and all that.
Can you imagine if we had to write those from scratch every time?
Yeah, cute. That'd be wild. That'd be super funny. Well, not really funny. That'd be more dangerous than anything. We did have even worse hacks of every website.
Oh my gosh. I remember the day, like back in the day, I didn't even know two-factor authentication was a thing. That scares me. To be honest, it wasn't that long ago.
It wasn't that long ago.
I don't even think it was a thing before relatively recently. Probably the last like decade or so.
This is your sign. I feel like a TikTok person. This is your sign to go have a photo shoot in a motel. This is your sign to enable two-factor authentication on all of your things, your banking, your social media. It's very important.
Okay. Also, talking to FA, the codes are more secure than sending a text to your phone number, because if you lose your phone or somebody steals your phone, they can still get access to your accounts. That's more on the companies who default to just using SMS for validation. But speaking of 2FA, I Googled it. 2FA came out in 1986.
Oh, wow. Okay. So it has been around longer than I have.
I was just
So it says, though there have been several predecessors to the modern day 2FA system, the 2FA that we would recognize today was made commercially available by the RSA company as a key fob in 1986.
What?
Oh, wow.
A key fob.
That's the key fob that I was talking about that I used at CAC.
Oh, wow.
I'm sure it looks different now.
We have like YubiKeys at work. And it's the best thing ever because people use sneeze in Slack all the time, which is when you just randomly press your YubiKey in like a Slack channel or whatever, and it's just a bunch of letters. I don't know. It makes me laugh every single time.
Well, I want to give a shout out to the whole country of Sweden right now, and maybe this is my shout out for the week, so we can skip me later. But one thing Sweden does really, really well is authentication. So when I signed up for a bank account, they gave me this card reader it looks like a calculator, but you stick your card in, and to validate with your online banking, you have to physically have this keypad that you enter your passwords and stuff into, and it'll give you a code that you then have to type in online. And you do that until you get this thing that's called Bank ID. And the whole country is using this Bank ID system. And basically, anytime you make a purchase online, it's all done with Bank ID. So you can create accounts with Bank ID. It's so nice because I don't have to remember username and passwords for anything. It's just like log in with Bank ID to your health insurance, to buy a product online, to buy things anywhere. Essentially, you're using your two-factor authentication app, and you can use Face ID, you can use like your passcode, but everything is done with this. And so honestly, Sweden is the most secure country I've ever been to.
That's so cool. Oh, wow.
That's really cool.
If you are interested in this topic, there are a few different courses that we recommend that you can check out. The first is a Coursera course. I like Coursera personally. Some other courses are hit or miss. But in general, I think you can take the course for free, and it's only if you want the actual accreditation or access to special things that you have to pay for it. Coursera is generally a great place to learn, so we'll link that one. There's also a cryptography crash course on YouTube that you can check out. And lastly, there's one on Khan Academy as well. So if you want to learn more, you could start with those three.
Cool. I love that they're free resources.
I feel like I'm kind of surprised, though. I'm kind of surprised they're not paid. This seems like an area that would charge money to learn some of these things.
Yeah, I think of it as such a college thing, too, that it's interesting that it is free, but that's cool.
It really is. This is not something that you learn in boot camp programs or as a self-taught developer, which is very interesting. And this is, maybe it should be. Maybe it should be something that we at least are made aware of from an authentication perspective, because I still struggle with authentication to this day, but it's important if you're going to be a developer.
We taught it at GA, kind of the stuff in here, but I had mixed feelings about it because it was one of those things where I was like, a junior developer is not going to be rolling their own authentication system. So I kind of I think that there are more important things for them to learn. But I do agree that maybe having some sort of security fundamentals would be really important. And we did that as well.
Definitely. And we actually have an episode this season with special guest Taylor Tolliver that talked about web app security. So we'll link that in the show notes if you're looking to learn some more about security that's maybe more web application focused. But with that, since I gave my shout out to the entire country of Sweden, Kelly, what's your shout out for this week?
My shout out this week is to Gusto, which is our HR and payroll solution. I've had a couple incidences occur over the past few months that have required their HR support that I'm entirely thankful for helping me navigate, because I am definitely not an HR expert and do not want to run into any legal issues. But most importantly, they helped me offer health insurance to my team at a very affordable rate. And as we're recording today, today is the day that the health insurance kicks in for my team. And I'm really, really excited to finally be able to actually offer this.
Mine is much lighter. It's Carcassonne, which is a board game. I could be pronouncing that wrong. I think it's Italian. But it is really, really fun. You have to have a lot of strategy for it. And there's also like expansion packs. So the game is always something different. I don't know. I have fun with it. So recommend. Especially if you're looking for we're almost like a year into quarantine now. This is nuts. So always looking for new things to happen.
It's a German-style board game that it's a shape the medieval landscape of France, claiming cities, monasteries, and farms. It's like real-life Farmville.
Yeah, it's so much fun. It requires so much strategy. Very cool. And again, you can buy these expansion packs and make it a whole different game. So if you're looking for a new challenge, highly recommend.
Board games are highly underrated.
Yeah.
Agreed.
Yeah, agreed.
Nice. Well, if you liked this episode, tweet about it. We select one tweeter to win a copy of The Code Book by Simon Singh this week. And it looks really, really cool. It got great reviews, and it'll help you learn about lots of things expanded on the cryptography topic. But we post new podcasts every Monday, so make sure that you are subscribed to be notified and leave us a review. And with that, hope y'all have a great day. You're welcome.